As discussed in previous videos on simple harmonic motion, Cook's law is obeyed, and the repercussions of this is that the position can be described as, in some generic form, as a cosine omega t plus phi, or you could also use sine. But tentatively, if you started at the maximum amount, at the maximum displacement, cosine generally makes sense. If you start it at 0, sine makes more sense, and that way you don't have a phase shift. And if it starts somewhere in between, it doesn't really matter which one you pick. So velocity is equal to negative a omega sine omega t plus phi, and acceleration is negative a omega squared cosine omega t plus phi. But also we're dealing with something that obeys Hooke's law. And so if we actually did a plot here of force and position, so if I needed to move an object up to a certain position, the force that required to do it basically looks like that. And I'm ignoring the sign at the moment. So this would be a plot of force versus the amount I actually have to move something. And I know that work, the non-conservative work, is equal to the change in energy. So if I take a spring in its natural position and I extend it out, so I'm not causing any change in velocity, I'm just moving it out at a constant velocity, so the force I'm applying is changing as I go. The force that I apply is going to be equal to, well, it's going to vary as I go. So this is force times displacement, and it's actually is equal to the change in kinetic plus change in potential. And I'm making the claim that there is no change in kinetic because in my thought experiment, I'm moving this out at a constant speed. And so this just becomes force times displacement. Well, if I have a changing force here, how do I deal with it? Well, I basically take the average force. So this would be the average force, or actually, since I'm moving it in the direction I'm applying a force in the direction I'm moving it, this becomes force times displacement, and this is average. So that would be delta x. Well, the average force, if I move it out to some position here, x, the average force is just going to be, well, it's halfway between here and here, so this is 1/2 of my maximum force. So this becomes 1/2 times my maximum force times how far I actually move it, which is x. And my maximum force is k times x. So this is 1/2 k times x, which is 1/2 kx squared. And that's the formula we've used before, or you could also put in, if you treat that as delta x instead of x, 1/2 k delta x squared. And that's basically where it comes from. There are other ways of deriving it, but that's just one way.